Alright, so this is a follow-up to the previous video where we learned how to check if a number is composite or not using a recursive function. Now, it's not limited that a function or a program has to be written in just one way. It can be written in several ways. So, for example, here we have another approach through which we can check if a number is composite or not. So here we are relying on the fact that if we find a factor other than 1 in itself, then we can conclude that the number is a composite number and we need not check for other factors of that number. So that is what we have utilized, that is the fact that we have utilized while writing this iterative program. So the interesting thing to note about this iterative program is that this contains the break statement. So we need to know what we should do when we encounter break statements in an iterative function. What should we do then? How should our recursive function be? And that is the objective of this video, right? So let's begin or start off with our class. And because we already have a class named composite number, I'm going to name this class composite number v2. Java.v2.scanner. That's the first import that we need to take, and followed by the name of the class. And the name of the class is going to be composite number 2. All right. Now, let's start off with a recursive function. We already know that because our recursive function already has a return type of Boolean, therefore we must type a Boolean as the return type for our recursive function. So Boolean, let's call this rec composite v2, and for the parameter list of the recursive function, the idea is same. The recursive function, the idea is the same. We see that the variables that have been defined outside the loop or just before the loop is num, result, and the loop variable is I. Right? So these all are going to be the parameter list. Boolean result and int I. Okay. So this is going to haunt me now, is it? It's fine. Okay. Now coming on to the base case. Now before we identify the base case, we need to know what our base condition is. So our base condition is our test condition is this, I less than equal to num by 2. And to get our base condition, we need to flip this condition. So the inverted condition or the base condition is I greater than num by 2. Base case. If I is greater than num by 2. Now we already know that from step 3 of the algorithm that everything that is outside of the loop constitutes the, for example, constitutes the, what should I say, the base case, right? So outside of the loop, we see that we have written result, all right? So this will be the content of the base case, return result. Then we will write our recursive case, else. Then everything inside of the loop is going to be written in the recursive case, as well as the update condition. Okay? So if num mod I equals 0, then what should we do? Then we must set result equals true, then we must break. Okay, so because we have break over here, break denotes that we are terminating this loop, isn't it? And terminating a loop, terminate a loop, we use break, and to terminate a recursive function, we use return with a value. So we know that if it breaks, if this condition is true, that means our number is a composite number, and therefore we must always return true, isn't it? If this condition is true, that would mean that our number is composite number. Therefore, instead of assigning result to true, we simply return true, and this put stop our recursion. All right. Next, if this condition is not true, then the update expression would be evaluated, and then we need to write our function call. And because this function returns, our function call will be preceded with return. So return rec composite 2, and inside of that we're going to pass num, result, and I. All right, and that's it. Our recursive function is complete. Okay, now let's test this recursive function by writing the main method static void main string args. Let's create an object of the scanner class to take input. Then we need to create an object of this class, call the method. For a number. Distinct if obj to num, then at the time of function calling we need to identify our initialization value. So num is not getting initialized because this will be the user input, but result is initialized with false and I is initialized with 2. Result is initialized with false and I is initialized with 2. Now if this returns true, it would mean the number is a composite number. So return, not return, I'm really sorry. We need to display system.out.println is a composite number. Else system.out.println num is not a composite number. That's it. Right? Let's run this code. See if it works. Let's give it 5. It's not a composite number. Let's give it 16. It is a composite number. Let's give it another composite number. Let's say 8. It is a composite number. Let's give it 11. And it is a composite number as well. All right. So our code is running. It's fine. It's running fine. But there's one thing that we can reduce in our composite function. So if you have noticed, is that if you find a factor which is, if you find a factor of a number other than 1 in itself, then we are directly returning true, indicating that the number is a composite number. So we are not really storing anything in result, isn't it? And if this condition is never true, then ultimately the value of result will be returned and false would be returned, isn't it? So therefore, what we can do is we can reduce our function list or parameter list by discarding of result and simply returning false here. All right, because we know if this condition is true, then it is a composite number. If this condition is never true, ultimately at one point of time we would reach this case, this base case, and we should return false then, right? And we will return delete result from there and would delete false from here. And our function would still work, but our function's parameter list has been reduced now. All right, so let's run this. Let's give it 5. It's not a composite number. Let's give it 16. That is a composite number. Let's give it 18. It's still a composite number. Let's give it 7. That's not a composite. All right. So I hope you understood how to convert the iterative form or iterative version into a recursive version, and the changes that I did at the very end to reduce the parameters of our recursive function. So if you don't understand, if you have trouble understanding this, then try this out on yourself. See, watch this video a couple of times. Try to make yourself understand. because you see, this is kind of like a mechanical rule to convert an iterative form into a recursive form, right? And this is something that I came up with. It's not there in the books, and it's probably not valid, but it still works. It makes your program run, and the code that you're writing consists of a recursive function because you're calling a function from within, right? So that's it for this video. See you in the next one. For now.